Ladies and gentlemen, we cordially invite you to get ready for the Zoom meeting. In a few minutes, the ceremony will commence. Assalamualaikum warahmatullahi wabarakatuh. Good morning. The Honorable Director of Universitas Negeri Semarang, the Honorable the Dean of Mathematics and Natural Science Faculty, Universitas Negeri Semarang, and all the audience. Firstly, we would like to welcome the keynote speaker, the distinguished guests, and all participants. Welcome to another happy occasion on which I am Muhammad Amar Hanan Fadila is happy and privileged to be your master of ceremony. We would like to express our gratitude to the guests of honor this morning for being present on this very special occasion that is International Conference on Informatics, which is organized by Faculty of Mathematics and Natural Science Universitas Negeri Semarang, Indonesian Chemical Society, Indonesian Physical Society, Indonesian Biology Society, Association of Computer Science Higher Education, Indonesian Mathematical Society, and Indonesian Science Educator. Ladies and gentlemen, as people say, the sooner the better. Let us now have our moderator that will lead our plenary session to Muhammad Ivan Aldorino. The stage is yours.
Greetings, ladies and gentlemen. On this delightful morning, I have the utmost pleasure of acquainting you with our esteemed presenters. Allow me to present to you the speaker for today, Abdurrahman Syafiq and Hanifianka Amelia Hampton. These brilliant minds are currently engaged in their academic pursuits at Universitas Negeri Semarang. Moving forward, I kindly invite both of them to take this reins of this meeting. On to you, Abdurrahman Syafiq and Hanifianka Amelia Hampton.
Yeah, thank you, Mr. Ivan. So on this occasion, we will present the material about image sketch-based criminal face recognition using content-based image retrieval. So have you ever seen the news or even experienced a crime where the criminal managed to escape and not leave a trace? It can be happen because in the law enforcement agencies, they often rely on a facial recognition tool to identify suspects. However, these photos are often unavailable in their databases. In such case, they seek assistance from skilled artists, particularly face painters, to create sketch based on eyewitness account of the criminals, even with limited observation. In this research, we will try how to find or recognize the face of criminals based on sketches and how to build photos or images of real face based on sketches. In this research, we use 5 methods. There are face image data collection, sketch face recognition, face image engineering, determination of face similarities, calculation search effectiveness, or Retrieval. The first method is face image data collection. It is the process of gathering a set of facial images for the purpose of building a dataset. In this research, a database was created using approximately 1,000 facial images depicting various poses, position, and brightness levels. The database includes image of normal face, facing perpendicular or at a 90-degree angle to the camera, as well as images of obstacles such as heads, glazes, max, or files. Additionally, the database comprises 700 images of unsuspected criminal and 300 images of criminal face. And the second method is sketch face recognition. It is a technique used to identify or match hand-drawn sketches of face with images of face in the database. It involves analyzing the features and characteristics captured in the sketch and comparing them with the features in the face images. So in this research, principal component analysis or PCA and Bayesian classification methods are used to recognize spatial sketches. PCA calculates eigenfaces, which are important representation of the shape and texture of the face in the sketch. Then facial features are projected onto eigenfaces to obtain compact and concave features. The Bayesian classification method is employed to predict the category or identity based on these facial features. With this method, facial sketches can be classified into appropriate categories based on the feature present in the sketch. So the third method is face image engineering. It is refers to the process of manipulating and enhancing face images using various techniques and algorithms. After the stage of generating facial images based on sketches, then to look for similarity, we use eigenfaces calculations. The eigenfaces method or approach in carried out for extracting vector features, which we will later use to classify and recognize faces. The simplified explanation is first, the set of face images is converted into vector, then the average face vector is calculated. Each face vector is compared to the average face vector to find the differences. Next, the vectors are transformed to reduce their dimension. Eigenfaces are obtained by calculating the eigenvector and eigenvalues. These eigenfaces represent unique facial features. And finally, the face image can be reconstructed using these eigenfaces. This process helps in accurately classifying and recognizing face for various applications. Next, determination of face similarity. It involves evaluating the resemblance or likeness between two or more faces. This is a complex and time-consuming process that requires advanced algorithms. To address this, three stages of matching face images are performed. First, looking for the topological similarity of the query face with the face in the database, which is a filter. Second, the information to fix the candidate face image that will be called. And finally, the matching calculation method is done to determine the similarity between the sketch query and the face image in the database. The recognition of normal and non-formal face or with obstacles that we work on this research can be explained in figure 1 and figure 2 on the next slide. So the figure 1 is normal face and the figure 2 obstacle face. Both go through the same process like what I explained before. We search the similarity between the sketch query and the face in the database. After that, we use more information to select the face image that will be called, and image will be matching, and finally the face image will be retrieved. The last method is calculating search effectiveness or retrieval. To measure the effectiveness of the research or retrieval, similarity method called Euclidean distance is used. This method calculates the distance between two images by comparing the pixel values in each dimension. The smaller the Euclidean distance between two images, the more similar or similar they are. In search application, this method is used to determine the extent to which the image in the database are similar to the image being searched for. And next will be explained by Mr. Abdurrahman Shah.
Mr. Abdurrahman topic, you didn't unmute yourself.
Okay. Next is result and discussion. For this our research, we have collect approximately 1,000 face images consisting of 700 non-criminal face images and 300 criminal face images. Moreover, each face image category includes a normal face or face without obstacles and face with obstacles. Face with obstacles, it means like a person who wearing glasses or wearing a mask or whatever. The examples of face image can be illustrated in this figure. The left side is the examples of criminal face image, and the right one is examples of non-criminal face image. Okay, so we did a software to implement our research, and then before it, we use the use case. We use the use case diagram tool to design an application system to evaluate retrieval performance. In this software, we include technologies like catch query, pre-processing, similarity, and the sketch view. And here is when we apply it to our software. Okay, next. So after the testing, the 75 queries were carried out in this work and detail of the precision and recall of image retrieval can be assigned in this graph. In the result, our precision got a value of 80% and recall got a value 30%. After we got data of precision and recall, we using F-score test to get an effectivity retrieval, and then we get F-score from the experiment of 0.6 or 60%. Okay, the conclusion. A precision value of 0.8 indicates that 80% of the data considered positive by the system are indeed relevant or true positive. In other words, out of all the results returned by the system, 80% of them are correct or relevant results. A recall value of 0.3 indicates that the system is only able to recall or find back 30% of the total data that actually relevant. In other words, out of all the data that the system is supposed to find, only 30% is successfully found. For this testing, an F-score of 0.6 indicates that the system can achieve relatively good level of precision and recall, but there is still room for improvement. But that is not a problem because there are no queries that produce a value of 0 in the precision value, but there is no failure in finding the image through the pre-count sketch. In the near future, research shall be carried out by using other methods such as segmentation, pattern recognition, or super vector machine, and using a bigger image database. Okay, so this is our presentation. Thank you, everyone.
Okay, ladies and gentlemen, that was the presentation delivered by Mr. Shafiq and Mrs. Hanifianka on the topic of image sketch-based criminal face recognition using content-based image retrieval. Before we conclude, let us take a moment to summarize the key points. The presentation highlighted the use of image sketch-based technique for criminal face recognition utilizing 5 different methods. Through their research and findings, Mr. Shafiq and Mrs. Hanifianka shed light on the potential of this approach in identifying and matching criminal suspects based on facial sketches. In conclusion, their work demonstrates the effectiveness and potential application of image sketch-based criminal face recognition using 5 different methods. Even though the recall value is lower than expected, the overall precision value and F-score remain high. The findings presented today contribute to the field of criminology and hold promise for improving law enforcement efforts in identifying and apprehending suspects. Let's give a round of applause to both Mr. Shafiq and Mrs. Hanifianka for their exceptional contribution and enriching our discussion with their valuable insights. Your present and active engagement have truly made this session a success. Thank you once again for your attendance and participation.
Ladies and gentlemen, we have finished our plenary session on this conference. Thank you to all participants who have joined this virtual computer science conference. I hope that this event has provided new insights, valuable experiences, and beneficial collaboration opportunities for everyone involved. This conference will not have been successful without the support and contribution of the speakers, organizers, and sponsors. I appreciate the dedication and hard work that has been put in to make this event a triumph. Furthermore, I extend my gratitude to all attendants who have shared knowledge, perspective, and innovative ideas in their discussion and presentations. This conference has been an incredible platform for expanding our understanding of the latest developments in the field of computer science. In closing, let us carry forward the connection and ideas forged during this conference and continue to advance the frontiers of knowledge in computer science. Thank you once again, and I look forward to future opportunities to collaborate and learn together. Wassalamualaikum warahmatullahi wabarakatuh.